Over the years, I've had a lot of luck building UIs into my CLI tooling. Perhaps the most successful example I've seen in my career was the Tanzu CLI provided by VMware. The cool thing about this CLI is that rather than remembering a bunch of configuration options and flags for creating clusters, the user had a UI option that would pop up a dialog, talk to the cloud provider, and through these dialogues help them set those different options. Behind the scene, the UI was just creating that same YAML file and those same flags to do the creation for the user, but they didn't have to understand all that complexity. They just had to choose options based on what was available to them. And while this example is really good, I think there's actually a case to be made for a far simpler approach where we're not using JavaScript frameworks or anything really too complex. The example I'm going to go over today is a utility called Proctor. Now, Proctor is a command line utility, and it enables us to do a couple things. One of the common things we'll use for Proctor is to list out process details, kind of like PS. Along with process details, it'll give us some information like what the path of that process is. Additionally, it will give us things like the SHA sum of that binary. And as a tool to explore processes, you'll typically find a process you're interested in here, and then you'll run a command similar to this get command with an ID provided. I'll ask for the output in JSON and pretty print it with JQ. And with this output in place, I now get a bunch of details about the process from the kernel's perspective, things like the virtual memory space, the resident set size, and all other types of settings. Another really common use for Proctor is to understand the hierarchical relationship of processes. So let's say that I want to run the tree command, and the tree command is effectively going to show what my processes I search for, so 58354 or go please, and then all the processes that were used to launch it. So in this case, we can go all the way down to the init system. We can see that was using SSHD. This then launched through Bash. VS Code Server then launched, and that's what called Go Please, which is the Go language server. So this is a case where VS Code is remotely pulling into a system to do coding, and these are the different processes that are kicking things and owning things to actually give us language server functionality. So Proctor is a command line like any other. It has flags, it has commands, but what if we want to provide an easier on-ramp for interacting with Proctor? Or perhaps just a different user experience? What if we could just go in and say sudo proctor UI, and then this would serve a user interface that we could load into our browser and get the similar result sets that we were looking at before? Additionally, what if it was navigatable? So we could go in and refresh and get a list of the new processes and their IDs. We could find the process we were looking for before. This time it's go please, looks like the ID has maybe changed. Click on go please, get information about all of the different kernel level details, and then view that process hierarchy again in a cool tree view with, again, hyperlinks that allow us to find some other process, click on it, and navigate to it. And the key thing here being, can we do all this with minimal overhead using the same libraries and data structures that we were using in our CLI utility? And that's what we're going to talk about today, how we can turn this Proctor UI command into something where it serves up an experience similar to that of the CLI. Let's take a look at the architecture that can facilitate this type of UI workflow. I think one of the key things when building out CLI tools, assuming they're not super trivial, is to think about the composition of our packages. My focus area when I think this through is really considering what these underlying libraries should be. And a lot of times I don't know out of the gate. I just kind of start coding everything in a main file and then breaking them out as we go through. But in my case, plib handles processes, sourcelib handles source code, GitHub handles metadata about GitHub. These are all features that are sort of baked into Proctor. And by pulling out these packages, I now have the ability to bring a CLI on top of it and consume these underlying libraries. Eventually, this will also enable us to bring a UI in and consume those same libraries. And there could even be a future state up here, which could be consuming these libraries to create services in a larger platform and so on. So just by generating these constructs, we have a lot of different ways where we can kind of think about what the import cycles will look like and how we can ensure that introducing something like a UI is really not recreating the wheel of our application. To start us off here, we are going to dig into creating that UI package. So if we look into the packages that are available out of the gate, we can see a couple: plib, source, platforms, and so on. And as the diagram suggested, we're going to start off with a UI package. Now we're also going to make a new file, and this is going to be inside of UI called ui.go, and this will be the definition of the package UI. Now to get us started off, we want to create a struct that we can instantiate from the command line that holds details about the UI. So this will be a type, It'll be called UI, it will be a struct, and it will have a few different parameters inside of it. The first parameter it's going to have is going to be an inspector. And this inspector is going to come from a library inside of Proctor, an existing one called plib. And it's going to have a inspector, plib.inspector type. So if we just take a quick look at inspector, this is something that's going to load processes and gather all of the available process information from a host. This will be a very key thing to keep an instance of inside of the UI. So along with inspector, we're also going to hold something called the data struct, and it'll make a little bit of sense later why we hold data. This will be things we get out of the inspector. You can think of it like we're caching results so that we can easily feed it back to the UI without having to call the inspector every time, but we'll get to the data definition in a moment. And then we're also going to create a refresh lock, and this is going to be part of the sync.mutext package inside of Go. Sync.mutext is going to provide mutual exclusion locks so that we can ensure if we have something like a refresh that could be updating processes, if we're doing a read, we don't step on each other's toes and end up with potentially bad data coming back to our client. So this is the construct of the UI that we'll be creating instances of. The next thing we want to do is create the data struct. So this will be data. And inside of data, since I know Proctor already, I know that I'm going to want to keep track of a couple things. The first thing I'm going to keep track of is the last refresh time. So refresh. And this will just be a time.time object in Go and will allow us to keep track of a structured date format that we could present in a multitude of ways over time. And then finally, I'm going to keep track of a variable called PS, and PS is going to be that cache, if you will, of the processes that we get from the inspector. So the type that we're going to grab here is going to be ps.processes, and this is actually, funny enough, just a map where the key is the PID, and then it points to another type in plib called a process. And you could probably imagine a process holds all the different fields that the kernel knows about relating to that specific process, all right? Now we're looking pretty good. What we're going to do next is we're going to create a constructor for this UI struct. So we need to be able to create a new instance of this. So what we'll do for the constructor is, I'll bring it up to the top here, we'll do a func, and this will be new. Since it's in the UI package, just calling new would make sense that it creates a new UI. It'll return a pointer to that UI, and we're going to do quite a few things in this initial constructor. So the first thing I'm going to do is declare an error variable, because there'll be multiple times where I'm overwriting this. And what we're going to do is start off by creating a new inspector that we store, and this new inspector could potentially be an error because the constructor we'll be calling is plib.newInspector. Okay, so plib.newInspector creates an inspector, takes an optional config, and could potentially return an error. With this new inspector created, we're now ready to set up the new UI. So the new UI is going to equal a instance of a UI, so that will be this. And we'll close it out here, and we can use the fill UI to get all of the different fields inside of here. So for the new UI, we're going to obviously set new inspector to new inspector. We will be setting data to empty, and then we're going to create that mutex as a brand new mutex as well. New UI is all looking good, and for now, if there's an error from this inspector here, we probably should do something with it. And just to make sure, in fact, I don't even think we need this var error, so we'll get rid of that. If error does not equal nil, so does not equal nil, we'll just go ahead and panic in this case with the error because it couldn't spin up the web server. We can get the full stack trace, all of that good stuff. So new UI is right here. And in fact, instead of storing new UI, let's just go ahead and return the UI just like that. And this will need to be, of course, a reference to that UI. And with all that in place, we've now got the constructor. Let's make sure you can see the whole thing, which will look something like this. So new UI creates a new constructor, holds that instance of the inspector, and initializes some default values. With the constructor in place, I know the next thing I'm going to want to do is set up kind of a run command that can kick off an HTTP server to feed our UI. So let's just think about how the composition of this API is going to look. I know that I'm going to have a root path, and I'm going to want the root path to give a list of all of the processes. I also know that I'm going to want to offer a refresh command that can go out to the system and get an updated view of that. So this will update, and then we probably just want, after the update, for it to circle back to the list all processes, so kind of like a redirect. I also know that I want to offer a process command here. So process / and this will be a arbitrary PID that gets put in, and this will give us the process details. And then finally, after we get process details, I also want the ability to get that hierarchy. So tree, right? Tree for PID. And I want this to be able to go out and give the tree for the processes. So parent processes all the way down to the init system like we saw in that initial example. So terrible handwriting aside, let's go in and start off by just setting some consts up that will store these paths. So at the top of the file, I'm going to go ahead and grab a new const block. So these will be constant variables that do not change. And inside of this const block, we'll do a couple. First, I'm actually going to capture the port because I know that I will be needing that. The port we'll expose on will be 8080, probably something we'd want to make configurable at some point. We'll do that refresh path, which we know is just going to be /refresh. We will do the process path, so process path. And process path will be the process / where the ID will come after. And then we'll do the process tree path, or we'll just call it tree path, I guess, to keep it simple. Tree path will be right here. This will be called tree, similar idea. And now we've got these consts that we can throw together. Now, if we go to the bottom of the file for a moment, I'm going to set up the first method on the UI struct. So to set that up, this will be a func. It will be UI, which is a pointer to UI or attached to a pointer of UI. This will then just be called run, and run will run the UI, as you could likely imagine. So when we call run, we will go down, and actually to keep this consistent with my blog post, I'll call it run UI. And now we're going to set up a bunch of different handlers. So handlers are basically a way for you to map a request that comes in with a function that can get called based on that request. So using the HTTP package, we can declare the handle func. Handle func will ask us, again, what that path is, and then what is the thing that we want to call based on the request coming in on that. So we'll do a UI dot. So this will be a new method that we will be implementing soon. And we'll call this handle all processes. Okay, so this is our first one. Then inside of here, we are going to do the refresh path, which we will say handle refresh. And then along with handle refresh, let's go ahead and do the process path const. And this will be UI.handle process. We'll call it details. And then as the final one, as you could guess, is going to be the actually just the tree path, I think is what we called it, right? Tree path, yep, which will be handle process tree. All right, so we've got handle process details, handle process tree, handle process refresh, and handle processes all set and good to go. Of course, these aren't implemented yet, but this is what will be redirected into. Now we'll just set up the actual listener itself, and we'll maybe just do a quick log statement that says log printf, and we will say that we are serving at, and we'll make sure we print out the port here in a string format. So we're serving here, and we will do this at the port constant. All right, and since this is a log f, let's make sure we do that. Great, we'll do a quick import of log. And finally, we will do the serve itself. So one cool way that we can kind of make sure we understand if something blows up is we can wrap this in a panic. And we're going to do HTTP, listen, and serve. And then listen and serve is just going to take the argument of the port. Okay, so this will be port. And then let's see what I know there's a second argument on this, the handler, if we wanted to provide a alternative handler, which we're not going to. So this will be nil. So now we've got run UI set up, and we've got all of our mappings inside of the UI package for what we want to do when it's time to hit or satisfy these requests. As a next step, let's code these handle functions. The second argument in the handle function is this handler, and handler expects an implementation that will be a function where there are two arguments. One is the response writer, and then two is the HTTP request itself. So to set these up, since they're attached to UI, we're just going to do func. We're going to put it inside of UI or call it UI and make it a pointer to UI. This will be handle all processes. Great. Handle all processes is again going to accept that writer, which we'll say is W, so http.response writer. And then for R, we will do pointer to HTTP pointer to HTTP.request. Okay, so this is our initial setup for the handle processes. We can see up here, it's looking pretty good. And now we can really just duplicate this for all of our other ones like refresh, all process details, and tree. So let's bring this to the top. And yes, we will start right here. So we will do handle refresh, we will do handle details, and then we will do handle tree. Okay. So with this in place, we now have all of these set up and registered, although we need to now implement them to put some logic in place. In this video, I'm going to focus on the implementation of just one of these handlers, primarily because refactoring everything and building it out will take a really long time. And I've got the source code linked in my blog that you can check out. But we'll focus on handle all processes so that we can understand the patterns and mappings that will be going on. And then you can check out some of these other ones at a later time, again, via my site. So handle all processes, how are we going to set this up? Well, the first thing I know out of the gate is that when we do these different function calls, there's certainly going to be mutation of data via refresh, gathering of data through that cache, and we want to make sure that we're not stepping on the toes of different processes. So the first thing we'll do is we'll grab the refresh lock, and the lock command uses that mutual exclusion to ensure that we can either block or gather the lock. And then using go, we can leverage the defer keyword so that when we exit this function, we release the lock. And that can be done via the refresh lock unlock command. All right. Now that we've got this all set up, we are ready to start getting the processes themselves. So inside of UI data, there is that PS field that I had mentioned before, and PS is going to allow us to cache a list of processes. And the call I'm going to make, I know, might also return an error. So this is going to be on top of UI.inspector, specifically the API call for inspector, which is get processes. So get processes is going to either using an existing cache on the host or by actually accessing the procfs file system is going to get process information and then return that back to us. So we're storing that in the UI struct as a local cache. If the error does not equal nil here, we are going to eventually return a error. So we'll do return error here. So this will probably be a status code to the client, but we'll come back to that in a bit. And then last but not least, if we look inside of the UI inspector, we'll notice that there's also a get last load time function in here too, or method rather. And get last load time will tell us when the last time that process information was gathered. This will be helpful in our UI. So we will capture this in UI.data in the last refresh field and store it there. Okay. So this all looks pretty good. PS is obviously not a new variable, so we're going to do this and say var error to capture that and make go happy. Okay, so we're capturing all of the processes. We are getting the last refresh. And the next thing that we want to look at is the templating itself. To get templates set up, I'm going to start off by creating a new file, and I've actually pre-created this in the UI package called static.go. So this file doesn't have much fancy going on. It's a bunch of variables that are storing static HTML. There are a couple ways to do this in Go. There's a way to actually statically compile external assets into the binary. But in this case, it's actually easy to use these variables. They work just great. So you'll see a pattern here. We'll start off with UI header, which is just the beginning of the HTML page, along with a bunch of style sheet information. As we move beyond that, there's also a footer. So this will be placed at the very bottom, closing some tags out. And as you could probably imagine, what will happen when we create our template is we'll start with the header. We'll start out with the custom content for that page or template for that page, and then we'll append the footer to the end as well. The one page I'll be focusing on coding out with you today is going to be the all process view. Now, this requires some knowledge of Go templates, but I'll try to do a little bit of it justice by explaining it here. When you use a Go template, what happens is you ask it to render the information, and a lot of this is just static info that will render as is. But then you'll see this kind of mustache or curly brace notation here. What happens when we run render is we're going to be able to pass an arbitrary struct into the render function. And when we render that, we're going to be able to access fields on that. So in this case, I can actually look up the last refresh data field. In fact, if you go back to our UI.go for a moment and go to the very top, you might remember in the data struct, there is the last refresh field. So you can kind of hint off of where we're headed. We'll eventually be passing this full data struct in. And as long as those are publicly accessible fields rather, we'll be able to access them here. And then we'll get down into probably the more important and complex aspect, which is the ability to iterate over that struct. So similar to how we were accessing a field, another field we can access is PS. And PS inside of here is going to give us this process list, which is effectively a map. So we can iterate over maps by looking at keys and values. And if we look here, we're capturing key and value just like that. So we're going to be printing out an HTML table that has the key right here. And then next to the key, and by the way, the key is like the PID or the process name, or I guess PID in this case, the key. And then we'll be able to access the actual fields on that, on the value. So things like command name and binary SHA are the things that we will print out in our HTML table. So it will effectively range through end here and just continue to print row and row and row and row based on which struct we send into it, which will effectively be data. So we've got static.go good to go. Let's now take a moment to look at the UI implementation inside of here. Back inside a UI, we can create the template. So to set up the template, this is going to be using the template.new function in Go. And this is going to start off with just naming the template. So we'll call this view. All right, and then when we've created the new template, there's a couple different things that we're going to do with it. The first thing we're going to do is tell it what we specifically want to parse. So these are going to be the variables that I had mentioned before. So we are going to start off with UI header. We know that we want to concat that to some other template, which is going to be the view all processes or all process view. And then we want to append that with the UI footer as well. So this will be the section of HTML pieces that get all brought together when this gets parsed. And obviously all process view is the one with those Go templates that we're going to be rendering as we go through. So once we create this new template, we're going to end up with a template that will store here or potentially an error. And if error does not equal nil, we will once again, actually we'll just copy this from here. We are once again going to have some error case we need to respond to the client with, and we'll deal with that in a moment, okay? So this is sort of our data gathering piece of the puzzle right here. And then this is our template rendering piece of the puzzle that we're going to want to look at in a moment as well. Okay, so the template's good to go. Now let's talk about doing the actual, not parsing, but I guess in this case, the rendering of the template, if you will. Okay, so with that template coming back, the next thing that we can do is on the template, we can call the execute command. So execute is basically going to say, give me something to write to. So this could be like a file. In our case, it's going to be an HTTP response. And then give me some data as well that I'm going to render against. That data is the struct I was telling you about, the specific struct that the Go template will expect to render. So for the writer here, we are going to push ourselves into W, which is what we captured in the function as the HTTP response writer. And then along with that, we are going to ask to give it UI.data, which will have the data fields inside of it. Reminder, these data fields are last refresh and PS, which is the cache of processes. Okay, so we've got t.execute being called here. This can also return an error. So we will do error equals. And then if error does not equal nil, we will once again want to do something bad here. So we'll return that error. Great. Okay, so now we're executing the template, and in theory, this should be the response we want to write back to the client. It should work without issue. Let's now test this out by doing a simple command creation where we can run something like proctor space UI and kick off this process. Now, if I run a make build in the Proctor project, this will build the binary out. And if we go to the build location out Proctor and run it, these are the current commands that are available. So again, what we're looking for here is to add a new available command that is called UI. And there are a couple places using the Cobra library for this project that we will wire this in. All right, so to wire in that CLI command, we are gonna hop back in. And in this project, there is a package called CMD, which hosts most of the information for how the command line utility taps into those underlying packages. So we can add the UI command. It's going to be a command on the root command. So this will be add command, and we will call it UI CMD. Now, obviously, UI CMD is not defined. So let's go to the definition of process CMD, copy that, and set up our UI CMD inside of here. So this is a Cobra command. Cobra is a framework that lets us easily create command line utilities with flags and arguments and all kinds of stuff. The use is going to be UI. We won't have any shortcuts or aliases. And then this will be create a web-based UI for Proctor. Okay, and then the command that we're going to run will be run UI, which obviously does not exist either. Basically, when this command calls, this will be the specific command that Cobra should run, which will eventually kick off our UI package. So to set up run UI, let's now go into something like run process here and do something similar. So if I copy run process and paste this here for run process, we're going to call this run UI. Okay, now run UI is going to be pretty simple for us. In fact, we don't even need any of this stuff in the middle. Run UI is just going to call that UI package. So if you remember, we have UI.new. New is going to create a new iteration of the UI, and then we can call run UI, which will register our handlers and run that server. So this is basically all we need to do to set our command up and get it moving. And I will just delete the comment for now. You can clean that up if you're writing your own and put something more descriptive in. So now we've wired this in, we've created a run UI function. We have set up a command in Cobra that describes how it should be used, and we've registered that to the root command. So we now, if we exit out, should be able to see that UI command. Let's do that now. So if I make build, and it looks like in command defs.go, I did mess something up. So let's see this real quick. Command defs.go, run UI. Okay, we did not specify run UI. Let's see if there's a typo. Run UI, which is, we probably should keep this consistent, right? So let's call this run UI, all capital. And now we should be good to go. So let's try this again. We will make build, run it out, Proctor, out Proctor. And now we have a UI command. So that UI command should be able to set up a user interface. We'll do out Proctor UI, and now we can see it serving at 8080, and we should be ready to check out the interface. Opening up a browser, we'll check out the final output here, and you can see that we now have a full table view rendered from that Go template with all of our different processes, the checksum of the binary, and they're all hyperlinked. So while this hyperlink won't do anything yet, you can see it is, you can assume that it's going to be navigating to that REST API that we have been setting up. And I'll show you kind of the finished piece here. And then we've also got a refresh button in the top that can eventually, once we implement it, can actually go in and refresh the process list and so on. So with this now rendering and being served up in its own little command, let me fast forward to the fully baked solution and talk about all the different things it can be doing. Back in the UI package, I've got everything set up and implemented, so I'll just kind of talk through all the different pieces that are going on here. So we still got our handlers registered and good to go, and handle all processes is still here, but it's a little bit more refactored. So what we've got going on here is when there are failures, in fact, I probably need to put this failure up here, to be honest with you. I have a write failure function when this happens. So whenever write failure needs to occur, I send a internal server error back to the client, and then I have an error view template that I parse. But other than that, for the most part, we are still rendering as is for this process. There's also a create template helper function here that returns the template back to the caller. This just abstracts that whole idea where we are bringing together the UI header, template, and UI footer. Additionally, if we go down to the handle refresh here, handle refresh acquires a lock, it clears the process cache, and then it actually redirects the client back to that initial root page, if you will. And then handle process details, probably the most interesting one. Handle process details is giving us a full list of the process details themselves. So basically you can think about it like everything that the Linux kernel knows about the process details. Now, what ended up happening with the process details, if you dig into the source code that you might find a little interesting, is handle process details required using reflection inside of Go to find the fields on the struct and print those back. So if I look over at get process details, in fact, I'll kind of scroll down into where the reflection's happening. This is a function that's going to go through and understand every field name in the struct and return a detailed key value. So the key will be the field, the value will be the actual kernel value. So this is kind of a cool little trick. It can be dangerous to do reflections, so you got to kind of know what you're doing, but effectively we are pulling all of that together. And if you do dig into the source code, what ends up happening from a template perspective is that we end up registering, let me find it in here, we end up registering that function of get process details as a function that we can call inside of the Go template. So this is kind of an interesting, cool thing. You can actually take an arbitrary name of something and then map it to a function in a Go template, and then you can call that function and render the results that come back from it inside of your template. So pdeets represents calling get process details. In fact, I'll just show you inside of that UI static file real quick. If we go down to pdeet right here, you can see that inside of one of the Go templates, I am calling pdeets. This is where I actually give it a process. That's what the dot is. And then pdeets is returning, again, that field and then the value. And then I'm creating a full table out of that. So there's a lot of stuff in here, but largely the key thing that you want to understand from a pattern perspective before you get too in the weeds about some of the Go nuances is that all we're doing at a high level is rendering a bunch of HTTP handlers to handle a bunch of paths, and we're calling those underlying libraries to make that possible. So if we take one more look at what the end state should look like, we'll make build in here, and then we will do a proctor out again for UI. We'll go back to our browser and refresh it here. Okay, and now if we refresh and click on some different processes inside of here, we can actually see a big process table that's going on. This is for process 1220 here. So let's click on, let's see what we've got. We'll do network manager applet. We can see a bunch of details. This has all happened through reflection to give us this fully rendered table of all the different details about the process. We can click this process hierarchy button, which will actually show us the details around that tree. In fact, what's kind of cool about this tree is it's respecting permissions. So if we did a sudo out of proctor UI real quick, so let's do that, I bet you we'll get even more processes because we should be able to see all the way down to the init system. So there we go. Now we can see nmapplet, XFCE, LightDM, and systemd, things that even our own user can't see inside of here. And since these are all hyperlinked in the template, we can click on them, we can get their details, and so on. So this concludes baking a UI inside of our CLI. Although we got into the weeds of some code, hopefully you can see how the patterns here are conceptually not that complex, and it's something that you can set up as well. And next time you're building a CLI, it might also remind you that it would be worth considering some of the details around how you structure your packages. Because again, this CLI was built fully with the green box pulling into these pink libraries. And then when it came time to have the UI consume them, they were all set up to fire through and gather that information as well. So I hope you found this interesting, something to consider for your future CLI creations, and I'll see you in the next one.